In this video, you will learn how to solve problems on dimensional analysis. A pycnometer is a glass apparatus used for accurately determining the density of a liquid. When dry and empty, a certain pycnometer has a mass of 27.314 grams. When filled with distilled water at 25 degrees Celsius, it weighed 36.482 grams. This is degrees Celsius. When filled with chloroform, a liquid once used as an anesthetic before its toxic properties were known, the apparatus weighed 41.428 grams. At 25 degrees Celsius, the density of water is 0.99704 grams per ml. What is the volume of the pycnometer and what is the density of the chloroform? So let's solve this problem. We are asked for the volume of the pycnometer and the density of the chloroform. So let's take a look at the given values first. We're given here the mass of the pycnometer, okay, which is 27.314 grams. And then when filled with distilled water, so that means the mass of the pycnometer plus the water is 36.482 grams. And when filled with chloroform, okay, there will be the mass of the pycnometer plus chloroform. It weighs 41.428 grams. And we're also given the density of water, which is 0.99704 gram per milliliter. Alright, so how are we going to solve for the volume of the pycnometer? Since we're given here the density of water, and we know that density is just equal to the mass over the volume. Alright, given the mass of the pycnometer when filled with water, we can solve for the mass of water here. So this is just 36.482 grams minus the mass of the pycnometer, which is 27.314 grams. Therefore, the mass of water is just equal to 9.528 grams. And now we can solve for the volume of the pycnometer. Okay, so the volume would just be the mass divided by the density. So mass of the water, which is 9.528 grams, divided by the density of water, which is 0.99704 gram per ml. Then we get the volume of the pycnometer, which is just equal to 9.56 milliliters. So now we already have the volume of the pycnometer. Now the next one is to solve for the density of the chloroform. Okay, how are we going to do that? We're given here the mass of the pycnometer filled with chloroform. So we solve for the mass of the chloroform first. Okay. Let's just delete this. Okay, we already got the volume of the picnometer. This is 9.56 milliliters. And then now we're going to solve for the density of chloroform. Density equals mass over volume. So we get the mass of the chloroform first. Okay, the mass of the picnometer filled with the chloroform minus the mass of the picnometer will be the mass of the chloroform. So this is just 41.428 grams minus 27.314 grams. Then the mass of the chloroform is just equal to 14.114 grams. Now we already have the mass of the chloroform, so we can now solve for its density. So density equals its mass, which is equal to 14.114 grams, divided by the volume. The volume of the picnometer, which we previously solved, this one, 9.56 milliliters. Therefore, the density of the chloroform is just equal to 1.48 grams per milliliters. Okay, now let's solve another problem. A 25 grams sample of a solid is placed in a graduated cylinder, and then the cylinder is filled to the 50 ml mark with benzene. The mass of benzene and solid together is 58.8 grams. Assuming that the solid is insoluble in benzene and that the density of benzene is 0.880 gram per cubic centimeters, calculate the density of the solid. So we're asked to solve for the density of the solid here. So let's take a look at or check the given values first. So we're given here the mass of the sample, which is 25 grams. And then we have the mass of benzene and solid. So mass of benzene plus solid is 58.80 grams. Then mass of sample is 25 grams. Now we can solve for the mass of benzene. Solid sample. Alright, so we just have to subtract this one, this mass, and the mass of the solid. So that would be 58.80 grams minus 25 grams. So therefore the mass of benzene is just equal to 33.80 grams. And we're also given here the volume of benzene and solid, which is equal to 50.0 milliliters. This one. But let's find, or let's solve for the volume of benzene first. So volume of benzene is just equal to the mass of benzene divided by its density. Okay, so we're given here the density, which is equal to 0.880 gram per cubic centimeters. So that would be 33.80 80 grams divided by 0.880 gram per cubic centimeter. Alright, so 33.8 divided by 0.880, this would give us 38.41 cubic centimeters. So this is the volume of benzene. Now that we already have the volume of benzene, we can now calculate for the volume of the solid. So we just have to subtract the volume of benzene from the total volume of benzene and solid. So let me delete this. So volume of solid is just equal to 50 milliliters minus, okay, so let's convert cubic centimeters to milliliters first. So 1 cubic centimeter is just equivalent to 1 milliliter. Therefore, 38.41 cubic centimeters is just equivalent to 38.41 milliliters. Okay, and then we subtract that, we'll get 11.6 centimeters. Now this is the volume of the solid. We already have the volume of the solid and the mass of the solid, which is 25 grams. Now we can solve for the density of the solid. So density of the solid is just equal to its mass divided by the volume. So this would be 25.0 grams divided by 11.6. This should be in milliliters. Milliliters. Okay, this would give us an answer that is equal to 2.16 grams per ml. So the answer is 2.16 grams per milliliters, or this is just equivalent to 2.16 grams per cubic centimeters.